Well, welcome to our GRG online meeting, and special thanks to Miles Jacobs. Miles sets up this meeting and had coordinated our speaker today. Our main speaker is Steve Becht-Buss, and Steve's going to tell us all about aging interventions with PCG1A TNF blood plasma context. And after that, I'll talk about my little trip I made to Austin, Texas, and had 2 liters of young, fresh, frozen plasma infused and my rather positive experiences. So, without further ado, I'm going to turn the screen share over to Steve and let's get started.
Well, Johnny Adams and Miles, thank you so much for having me. And it is great to have so many people here. I'm presenting a hypothesis today about anti-aging blood-based interventions, their unique mechanisms of action, but also what they have in common. Let me set my timer. I have my timer set. Um, Readings on the right. I've been interested in longevity science a long time, 12 years. I have a lot of hours in it, but I'm an independent researcher. This is my hobby, and it's an extremely interesting hobby. So the game plan is I'm going to talk for 30 minutes, and I want to get through the entire presentation. Uh, and then any questions and discussion you want to have, I would love to talk with you about this topic, and I will stay as long as you like. But I would like to get through the presentation. So I sent the PDF as an attachment to the new chat email, the new meeting email that Johnny sent. Uh, my research activity, I have 2 goals: to present this hypothesis of what the 3 interventions have in common, and then also perhaps help you to understand how beneficial generative AI, chat AI, tools like Claude's Sonnet 3.5 can be. This is version zero point 0.5 of the presentation. I'm happy to share the slides of something approaching version 1, but only a few slides from the current version. We'll talk about blood interventions, common elements, blah, blah, blah. Q&A, I'll stay as long as you like. About Gen AI and Gen AI errors, I've actively collaborated with Anthropic Claude Sonnet on the presentation. All the key ideas, the big ideas I came up with just for my own research. But because I engaged with Sonnet about the presentation content, it is dramatically better than it could ever be if I had just done it myself. And I'm not going to go into detail about some basics, but let's get started. You can see I'm a blood donor, as a Red Cross. Plasma dilution. I think one of the most amazing studies published about blood interventions was a study published by the Convoys in August 2022. And what they found was that plasma dilution reduced human biological age through one of the epigenome aging methodologies, uh, really made famous by Steve Horvath. And this is just a picture of what they discovered. What's happening is that the same biological epigenetic age and gene expression analytical tools are being used by both plasma dilution study teams and teams doing deliberate Yamanaka, OSKM, partial epigenetic reprogramming experiments. I'm with Johnny Adams in believing that these blood interventions are the most significant game in town. And there was another amazing insight that I gained from this Convoy study. I think it's one of the most uh, important studies published since 2020. Uh, in the abstract, they said that mechanistically, the circulatory regulators of the JAK-STAT, MAPK, TGF-beta, NF-κB, and toll-like receptor signaling pathways become more youthfully balanced through normalization of TLR4 that was accomplished via plasma dilution. Now, the reason this was such a big deal for me is because I am a longtime fan and student of something called the cholinergic anti-inflammatory pathway. When I say there are three blood-related interventions, I'm talking about plasma dilution, Younging factor addition, and the cholinergic anti-inflammatory pathway. That pathway, called the CAP, I'll call it the CAP from now on, the cholinergic anti-inflammatory pathway, is a brain to spleen mechanism that reduces inflammation in the blood circulation. And what I noticed is that in figure 2 of Kevin Tracy's article, literature review about the CAP, the cholinergic anti-inflammatory pathway inhibits inflammation from occurring through the same pathways that the convoys referenced. In other words, plasma dilution and the CAP have something in common. We'll be talking more about this. Another profound studies that have been going on have to do with young plasma, of course, and they have also been shown to increase epigenetic change and increase survival probability. There are multiple studies. This one on the left. Let me get my laser pointer going here. There we go. This one by Harold Ketcher and also Steve Horvath. Reduced epigenetic age. Here's a display of that in the center. I want to point out that TNF alpha is shown to be reduced when young plasma extracts are given to older rodents. Here I want to show, I just include this diagram to show that young plasma extracts also increase survival probability and they trigger epigenetic change. Most people are familiar with young plasma extract addition and plasma dilution. Most longevity movement people are not familiar with the CAP. So I have two slides. I want to show two slides about that. The CAP is not some alt health fad. It has a huge literature in plain sight. It's the motor arm of the inflammatory reflex. Hundreds of scientists and hundreds of studies have described and explained what the CAP is and does. It's a potent reducer of inflammation, and it can profoundly increase survival probability. High-level objects, its brain, spleen, the blood circulation system runs through the spleen, and that's what it has in common with plasma dilution. There's blood circulation in common. This is a diagram from a study about the CAP. This red line here, I drew that in because in studies of the CAP, these academic students of the cholinergic anti-inflammatory pathway don't often put in the fact that the blood circulation runs through the spleen, and the spleen is where the anti-aging and anti-inflammation effects occur. Survival probability impacts, huge survival probability impacts. I'm just going to tell you that they exist, and I can review what the studies are in detail later. So we have to ask ourselves, this question has bothered me for a good while now. We have three plasma-related interventions, but those are the interventions. Those aren't the biological mechanisms of action. What are the biological mechanisms of action for them? Let's see. This is one of the, shoot. This is, what do I do when, there it is. I have to click the forward button. There are two ways to think about what the interventions are and how they might work. They could work with each intervention having its own entire mechanism of action for achieving a few of the effects. So we have increased young factors, aging factors, cap activation, and each of these could theoretically have its own complete own mechanism to achieve these beneficial effects. Is that how it takes place? Another approach is to imagine that each intervention has its own unique mechanism, but triggers a subsequent cascade of, of mechanisms and processes that trigger the establishment or the moving toward of a systemic plasma contact. And it's the systemic plasma contacts that all of them have in common that achieves these beneficial goals that we're all interested in. And I drew in these numbers to make the point that each of these interventions, taking this view of how things work, is a multi-step process once the actual intervention is implemented. And the amazingly good news is we now know a lot about what those steps are. And so we can see if we can establish a reason for believing that this second approach to understanding how they work is actually how they work. I'm on track on time, I think. So let's think about this. This big pink box is a high level set of statements about that small systemic plasma context. What do we, how should we think about it? Well, it's defined by the specific relative concentrations of pro-younging and pro-aging factors. And both of these are present in the plasma. And they have to have, in order for these interventions to make a difference in our lives, they have to have intracellular effects, of course. The core mechanisms, if this picture of how things work is true, is that the specific interventions must be antagonistic to each other. We don't often talk about that, but the younging factor needs to be mutually inhibitory to the aging factor. There must be direct molecular opposition, right? In order for these interventions that we're all interested in to work, it sort of needs to be like that. And they need to compete to regulate certain fundamental processes. Sometimes they can have nonlinear effects and they have self-reinforcing feedback loops. And it's really all about relative concentration of effects. These two mechanisms, the three mechanisms, must be a part of an evolutionary and systems biology context. They must be ancient evolutionarily conserved mechanisms, especially the cholinergic anti-inflammatory pathway. They must be integrated into core regulatory networks and affect multiple critical cellular pathways. Stay on track of time. I'm going to move on from this. Now, I wanted to show you, first, in order to talk about what they have in common, I had Claude Sonnet generate a report. And a lot of information on this is correct. There are a few hallucinations that occurred, and so I'm not distributing it, and I won't include it in the slides until I have a version without hallucinations. But the thing I wanted to point out is that even though there are a few issues with it, this is an incredibly valuable generation of ideas. And I also have a generation of study references for each of these cells that Claude Sonnet provided me with. So even when Sonnet is hallucinating, it can still get 80% right, 90% right. I'm certain that there are errors in the presentation, that are a result of Claude, but they can be easily found. Here's another version of the same thing. Now, this is the key slide containing details about how they might be related in that second approach. And I should tell you, I have been won over by the evidence that something like this is precisely what's going on. I think we know the general framework about how it works, and I think we know the two key cellular, molecular, biological object factors that are, in fact, the aging factor, the key aging factor, and the key younging factor. And the fact that they're known in two studies, they are declared, they are demonstrated to be the key younging and aging factors. So I sent a PDF file to the email that Johnny, as a reply to the email that Johnny sent announcing this new meeting this morning. And I'll happy to talk about it in detail. The letters are small. I'll just review the column headers. We have the three factors across the top.
Oh, Steve,
Historically,
sorry to interrupt. I did go into the admin panel and forward it to the group.
okay, great, great,
So
great,
it's in
great.
your email inbox, everyone.
Right. I when I do these kind of sort of
She's coming back.
thoughtful, reflective things, it takes me. I work on it right up until the meeting, and so I didn't get it to you early. So the three interventions are noticed at the top: historical development and evidence.
I will watch it with my heart.
I'm sorry.
If you want, you can put it here for now.
Yeah. So
Oh, sorry. Yeah. Let's
so
keep it like that. Yep.
no questions now. I'll take them later. Implementation methods. What's the initial implementation approach to? Oh, you're not seeing my laser. Yeah, I think you are. The initial implementation method, and then a list of the follow-on activities performed by each of the interventions, along with a statement of what the molecular cascade effects are. And Claude Sonnet helped me to put this content together. I imagined the diagram, I did the big picture thinking, and I filled in all the cells. And I went through 2 or 3 rounds of let's enhance this, let's get all the details right. And Claude Sonnet was invaluable in accumulating and gathering together
Couple
all this.
people already tried to take the table.
I'm sorry, what? So we have the systemic impact. What is the systemic impact? That's what we want to know. Each intervention through distinct mechanisms drives toward a common homeostatic state characterized by enhanced cellular repair via TGC1A and TNF optimization, reduced inflammatory burden via TNF pathway modulation, improved metabolic efficiency, tissue-specific regeneration, biomarker improvement. And then we have some other effects. We could talk about these. Claude Sonnet pushed me to say, Steve, if you want to distinguish between these interventions, you need to talk about effect, timing, and duration. And I have included effect, time, and duration. I have not done the research to verify that these are completely validated in the literature. But once I do that, then I can put in the correct information, and we'll have it in a single table. Next slide. So I want to talk about a special case, about this red part. What I say here is that the key factor in plasma dilution is plasma dilution of TNF, well, the convoys actually didn't say it was TNF. What the convoys did, and they couldn't say what the key factor in the plasma was, because they diluted in that intervention, all the plasma is diluted, and there's no figuring out of what plasma elements are the most important for achieving the intervention goal. However, that said, I believe that, and that's what I mean saying here, there's an indirect effect. I believe there's good reason to be certain, to be relatively certain, that TNF inhibition in the plasma is the key element that is diluted that causes the benefit of plasma dilution. And let me walk you through this logic. For Younging factors, there is direct evidence in the 2024 Chen study that PGC1A is increased, and Chen et al., that's the April 2024 study, they say if we blocked PGC1A from being increased, then the Younging effect didn't actually occur when we did the Younging plasma intervention. So we know that PGC1A is a necessary independent variable for young plasma. We just don't know if it's sufficient, completely sufficient. Now, for the CAP intervention, which, by the way, you'll recall, we saw a minute ago that the cholinergic anti-inflammatory pathway was inhibiting the same intracellular pathways that the convoys said were inhibited with plasma dilution. CAP activation, the factor that is inhibited is actually TNF. It's been demonstrated that TNF is the key to the anti-inflammatory effect that the CAP has. And you'll recall in Harold Ketcher's study that I just showed two figures from a minute ago, Harold Ketcher understood, right, that even though he's not doing plasma dilution intervention, he's still showing, TNF in the blood is reduced. So what we know from massive, really what amounts to overwhelming research, is that PGC1A and TNF are mutually inhibitory. They have that kind of antagonistic relationship with one another. So they have mutual inhibition. TNF controls the CAP, and these two pathways, you'll recall, are mirrors of each other. And so it makes sense that we can presume, with some degree of doubt, but mostly presume, that TNF is the factor for plasma dilution also. So now I wanted to speak to the effects of PGC1A and TNF. I'm going to move quickly. PGC1A and TNF in the mitochondria, they are involved vis-a-vis the same biological objects in the mitochondria that the other is. One is antagonistic. One promotes cellular health. That's PGC1A. And the other damages, impairs, or disrupts cellular health with fission and fusion, with ROS production, the electron transport chain, and on and on. At a mitochondrial level, these two factors are in fact in opposition to each other. They have effects that are antagonistic to each other. Same thing in the nucleus side. They have antagonistic effects. This is the slide. We can talk about it later. This is version 0.5 of the presentation. I'm going to be creating all the updated as we go, and I'll have slides later. I'm going to move quickly to get done in 30 minutes, like I promised Johnny Adams. And in the blood plasma, here are the effects they have in the blood plasma. These kinds of lists are easily generated with Claude Sonnet and other GenAI tools. There is a way that conversations with GenAI tools have to take place to minimize bad answers, wrong answers, silly answers. I think of Claude Sonnet and other GenAI tools. They are idiot savants. They are savants. They can also be idiotic at the same time. But if you are working in a topic that you have expertise in, it's not that hard to pick out where they're getting it wrong. And I challenge Sonnet all the time and say, you know what, I think you got this wrong, and it will apologize and say you're right. So that's not a problem for me, and the speed with which I can put together content makes it worthwhile to do. Now, you saw a diagram of this previously. This is a mermaid. It's called a mermaid diagram. It's a diagram that Claude Sonnet generated the pseudocode for. And what I wanted to say about this is a really fascinating topic, because TGC1A and NFKB are both involved with something called P65. P65 is a protein that is a subunit both of the telomerase enzyme and also of NFKB. Let me say that again. P65 is a subunit of NFKB and telomerase. And so how does that work? And PGC1A, it turns out, is in competition with NFKB to capture P65 within every cell. And I put a bunch of information in a prompt for Claude Sonnet, and said, does this make sense? Should I present this information? Do you think it's important? Is everything I've said accurate with the literature? Claude Sonnet came back and said, yeah, everything you mentioned is a true statement per the literature. Do you want me to draw a diagram of it? And I said, well, yeah, let's see what you come up with. And this is the diagram it drew. You'll recall that astragaloside 4 is an astragalus variant, as is TA65, right? TA65, the telomere lengthening product, is also an astragalus kind of substance. And astragalus promotes PGC1A to make it active, and PGC1A competes for P65 along with the NFKB complex. They compete for P65. PGC1A, when it's active, it can promote telomerase expression with healthy effects. With one problem, though, you don't want to have telomerase promoted with inflammation. It turns out that astragaloside 4 is also an acetylcholine herbal supplement, and it increases acetylcholine and has been shown to reduce inflammation at the same time. And when the CAP is active through CAP activation, then you get healthy effects from telomerase. In other words, when TGC1A is involved, you get healthy effects. When NFKB is involved, you get an inflammatory state, an increased telomerase. I didn't tell Claude Sonnet how to create this diagram. It did it on its own. I have 2 minutes. Here's another version that I haven't checked it. I don't know that there are hallucinations here, but Claude kept pushing me to define durations of effect. And it even without asking for me to do it, it plays durations of time between these steps. Right here are the three interventions, durations of time between each of the steps. The next thing for me to do for this slide is to ask for the references, and I will get it from them, from Claude Sonnet. So I see the cap like this. There was this reality of aging factors and younging factors in the blood plasma characterizing all of life that had circulation system of the more advanced species. This is my speculation now, okay? I'm speculating. But I think that's true. And I think the emergence of the cholinergic anti-inflammatory pathway was a response to that pressure of the fight of younging factors versus aging factors, because the cap inhibits inflammation and reduces TNF. And that's the point of this slide, to provide details of how that works. I'm getting done here. You may recall that in 2007, two gentlemen in, I think they were at Stanford, Howard Chang and I think Adam Adler, they might have been smoking dope. I don't know. What they said is that in their study called Motif Module Map Hypothesis, NFKB enforces aging. They said if it wasn't for NFKB expression, then aging doesn't take place. Now, their study was in vitro, wasn't in vivo, but the truth is they said aging is taking place because of NFKB expression. And in fact, because the younging factor key variable, PGC1A, is antagonistic with NFKB, one wonders if they didn't have prescient insight into its role in aging. And when I asked Claude Sonnet to generate a diagram illustrating this point, this is the diagram it generated. Presentation summary. There are three blood interventions. Two of the substances are ancient. One of them increases younging a bit. The other increases aging and health problems a bit every day when they're expressed. That's PGC1A and TNF. Here's the aging context. Aging factors, young factors. There are three interventions that all three have been demonstrated to increase PGC1A or reduce TNF, and TNF and PGC1A are antagonistic to each other. That's what this line here is about. And when these interventions occur, you get increased mitochondrial health, reduced inflammation, tissue regeneration, among other things. Finally, I think in my opinion, we've reached a new stage in the longevity science movement in many ways. Among those ways is that it's time to move away from just focusing on interventions and to focus on mechanisms of action. And there's one very practical reason why. There are numerous other ways to increase PGC1A. And I'm happy to discuss what those are in the Q&A discussion period after. Thank you.
We're going to handle the Q&A a little different this time. I have something that's very valuable that intersects with what Steve talked about.
And I had a little fun yesterday sending out an email to probably part of this group. But I think what needs to be realized And oh, by the way, I have the registered trademark, the dilution solution. But apheresis was first used in 1960. The Apheresis Society, and I used to supply apheresis, total plasma exchanges, with saline in the early 70s. The Apheresis Society formed in 1982. There are currently 450 hospitals in the United States that perform 30,000 total plasma exchanges a year for what has been now classified as 85 conditions, the majority of which are inflammatory problems, inflammatory diseases, etc. It's also a fact that there are 1,000 locations in the United States that will pay you to undergo a plasma exchange with saline, and that gets performed 50,000 times a day. So when I hear about the convoys doing 5 rats in 2020, you really got to get a grip on we've been actually doing this for 55 years in humans at a massive volume. Also, what was put out, again, having a little fun yesterday, is in parallel with apheresis is what we commonly call hemodialysis. In fact, you can use a hemodialysis machine to perform plasma exchanges. They're also sold by the same companies, Fresenius, they're sold by Terumo, and as we all know, hemodialysis is performed at a massive level every day worldwide. Fresenius itself runs hemodialysis centers, and last year they netted $3 billion from it. So again, be careful, running around with the rats and people doing these things and not looking over to the big picture. But the similarity between apheresis and hemodialysis is direct because fundamentally they're the same process. And the reality is you can dilute yourself all that you want. And again, don't confuse it with a blood donation. Blood donations are debilitating because you're losing cells. When you do apheresis, you're only addressing your plasma and you're diluting it. But the fact of the matter is, it's like taking my old truck down to have the oil changed every day. It's not going to fix it. It'll make it run as good as it can, and it'll lower the inflammation, but it won't fix it. Just the same as people, it's almost 600,000 people who go in for hemodialysis 3 times a week never have their kidneys recover. They just keep their blood clean, but it doesn't fix anything. There's an individual here in San Diego. I spent 10 years on the UCSD Chancellor's Council and the boards of the university. And I'll end this pretty quick. One comment about AI. Since I have AI technology in the time capsule at the university to be opened on its 100th anniversary, should I live that long. But the real fundamental fact is that you're not going to find apheresis and you're not going to find hemodialysis to restore you. Just real quick, you can talk about Harold the rat catcher all you want. He's caught a couple rats. His elixir is exosomes. Well, there's 10,500 proteins. There's 5,000 peptides. There's 45 cytokines. There's 50 sex-specific hormones. There's 1.84 billion exosomes per ml in plasma. But unfortunately, to go from a rat, like Harold talks about, into a human, you have to sterilize it. So I'll go offline with Josh and all of us. We can talk about quantum biology, because that's another elephant in the room that gets missed in these conversations. Because we've known for 100 years with blood, we've known for 70 years with organ transplants, we've known for 50 years with IVF. The only thing that transfers life or creates life is life itself. You cannot create life in the absence of life. So chemicals and sterilized biologics aren't going to get you there. And it's naive to think that you're going to come up with a magic molecule that is going to then fix you like some sterilized exosome is, because that sends a signal. You need all the cohorts. They all need to be living, not dead. But anyways, the last thing, of course, I spent a long time in the field of AI. And so don't kid yourself. We understand about 4% of quantum physics. That means about 96% we don't understand. AI today compiles conventional wisdom. But if that wisdom, 94% of that wisdom is absent, AI is not going to give you any insights. It's just going to regurgitate the same information and maybe summarize it for you, but it's not going to find the answers that we ourselves have not yet found. So don't delude yourself that you're going to find AI to be any guiding principle in the field of quantum biology. And the last part is, we've done 1,000 humans with young plasma. We know what it works. We know it works. We know how it biohacks us. And so, I'll leave it now to Johnny and to Walter to talk about their recent experiences. I've had a lot of it myself, but look at the big picture. When you talk about dilution, we've been doing it for 50 years. Look at the big picture when you talk about cleansing your blood as an answer, because we've been doing hemodialysis and apheresis for decades and decades and decades in humans, not just 5 rats. So put all of this in perspective, and the good news is the answer is right there in front of us, and it's the transference of life. You don't transplant into somebody a dead heart. You transplant them in 4 hours while it's still alive. You transplant biopreserved plasma from a young sex-identified donor, and you do it when it's alive. And even the roundworms in the Siberian permafrost that woke up after 46,000 years, horny and ready to reproduce, which they did, realize that life can be preserved. But the woolly mammoth next to it that died and got frozen is never coming back. So there's a few principles here, but I'll leave it at that.
Well, good. Thanks, Tom. Well said. A big point to remember with the young plasma is that unlike most single therapies and combinations, it affects an extremely wide range of therapeutics and hallmarks. And I know some of you have seen this before, but for those of you who haven't, these are key overriding points that you need to know about. So they renew and well, like Tom said, they fix stuff that an oil change, just removing, replacing with saline can't do. That's Yamanaka OSK, which is something that a team I'm working on with here in Florida is working on. We're hoping to have this coming down the line in a few years. Until then, we go with what we have now. So clinical evidence leads us, or me anyway, which I'm hoping to present to you, that the best age reversal therapy we can do right now is therapeutic plasma replacement. It is safe, and I'm going to show you some numbers as soon as I get through this fundamental part to show you my experience as to its efficacy. And we'll stay tuned to developments in others and help with what we can. Gene therapy, mitochondria. I love what Tom Benson's doing, but more power to him. He's pushing a big rock up a hill. Senolytics, microbiome, I call them the usual suspects. I do a lot of these things, as do most of you. And after that, we shall see. I don't have the luxury of time, tick tock. Do you have a better plan? Let me know. So I'm leading the plasma project, and I'm just going to rip through. Okay, therapeutic plasma infusion. Maybe some whole blood out, but probably, but infusing young plasma, and you infuse matched, thoroughly screened plasma from healthy donors roughly in the early 20s. That's what I did. That's what Walter did. Research shows that donating plasma, these 18 to 25-year-old donors, that donation process is good for them. There are cognitive, athletic performance benefits, as well as health benefits. And I wrote up a little paper on that, which I'm constantly updating. You can have it if you want. So the second variation of this is old plasma out, saline and often albumin in. Sometimes we follow with an IgG push for immune system, and therapeutic plasma replacement, old plasma out, young plasma in. Plasma donation is safe. Concept is based on the early experience with the rats. Minimal side effects. I experienced some minor, it felt like little bug bites and a couple of other minor things, but the benefits are great compared to any side effects, and we can talk more about that later. It's safe. I'm going to rip through a lot of stuff. Plasma is natural. Look, it's like 3.5 billion years in development. It's not cooked up in a lab. So, I mean, I don't mean to be demeaning towards bench scientists who cook things up, but to my mind, plasma is better. It's natural. TPE gave me outstanding results. And this is a main take-home point, background you need to know before I show you my biomarker results. This full range of balanced and complementary components in young plasma, and there are thousands and thousands of them, to my mind, seemed that they would be more effective than one therapy or even several in combination. I know sometimes one therapy has some multiple effects, but here you're getting thousands and thousands of complementary components in plasma. And the balance is consistent with the target we're aiming for, I'm aiming for. I don't know about you. It seems like everyone would want to have a more youthful phenotype. Okay, so plasma, liquid part of blood, most of you knew that. Here we're getting into some important points. It contains thousands of components. Some of the high-level components are exosomes, cytokines, growth factors, metabolites, nutrients, miRNAs, regulatory proteins, hormones, enzymes, mitochondria. Tom Benson advised me at a previous meeting that, yeah, put mitochondria in there. Josh advised, well, there's not a whole lot of them, but hell, I'll take what I can get, okay? Minerals, electrolytes, albumin, antibodies, and plasma reaches systems throughout the entire body. It affects a full spectrum of therapeutic targets and hallmarks of aging. Okay, here are a few examples of the thousands of components. Let's start with exosomes. Tom nailed it. 1.84 trillion exosomes per liter, and exosomes are cell specific. Yeah, you can get them from placenta or whatever, and they may or may not have some value, but with these 1.84 trillion per liter, multiply that by two for the 2 liters that I had, they affect every part of the body. Exosomes from plasma are not damaged by processing. And one expert reports that exosomes derived from other methods are sterilized. No one, well, hardly anyone really notices them, and they are 30 times less efficacious. I don't need to take you through all these points. Okay, cytokines. Here are just a few of the kind, and it was tumor necrosis factors. I suggest to you that in the young plasma you're getting, things like that are detrimental, inflammatory, like TNF alpha, that you're getting proportionately less, probably a lot less. If you want to do a study and you want to measure them, power to it, you can do it. But I think it was Steve who pointed out to me that PGC1 alpha attenuates TNF alpha. And then here are some of the others. Okay, I'm going to rip through these growth factors. GDF11, bless Steve, he was a good friend. I was on GDF11. It moved the needle, it moved my biomarkers a little bit, not nearly enough. Okay, other growth factors, and lots more than I've listed here. Mitochondria, miRNAs, here are a few, many more, hormones, albumin, antibodies, nutrients, metabolites. This is a chart that echoes and expands upon some of the things I've said. Everyone go to youngplasmastudy.com and watch Diane Ginsburg's video. It's right near the top. This is the single thing that triggered my enthusiasm about young plasma and put me on the road I'm on now. Here is one of Spectrum Plasma's informationals that echo some of the same things. Here's the take-home point. Tom talked about this. Young plasma is biologically active, and there are debates that go around about what life is. I suggest to you that when you quickly freeze something and then introduce it into another human, that it either is still alive or it has the components, the important components of life. And life begets life. I've not known, except with the very early beginnings of life, of something inorganic just automatically popping up and becoming live without complicated steps of billions of years of evolution. Couple of examples: in vitro fertilization. To the best of my knowledge, they fast freeze them. Hearts, they freeze it very quickly or they move it from one human to another. Spectrum plasma, which they have this down to a system. That's where I got my plasma. They test it far beyond normal commercial plasma donation center standards. These are a few of the list of what they do. Here's some more information about it. So, yeah, I already said this. So there's evidence, and I'm going to show you some studies. I have to rip through it really quickly, but these therapies help with dementia, Alzheimer's, and Parkinson's. Okay, they interact in a complex network. It doesn't actually look like this. This is just for a representation of the interaction. This is John Ferber's chart, just showing how complex networks are. Okay, now, here are some published peer-reviewed studies. There are some questions with these. We can talk about it offline, maybe later. I hope Diane's here, or maybe Tom can address what I call the dirty underbelly of this research and how it's tied into pharma. But all right, here's some studies, more studies, more studies. Got to rip through this. I have to get to my biomarkers. You can have these if you want them. You can search clinical trials, PubMed. I look to doctors for results. And yeah, you could argue that they have a self-interest, but they have their medical licenses on the line. Here are what a couple of doctors who regularly treat patients have to say about it. Tony Weiss-Correa, He's kind of a big deal at Stanford, and here's his video and a webinar he put on. A couple of other guys, I got to rip through this. These are some examples of conditions approved for plasma infusion. Autoimmune, there are some kinds, blood, neuro, metabolic, kidney, toxins, post-transplant complications. I have a couple other documents I can send you, which include highlights of Diane's presentation and some testimonials and commentary. All right, you've seen this already, got to rip through. That's me sitting in the chair, big smile on my face. Finally, since 2015, I've wanted to have this young plasma infusion. Finally, took a flight over to Austin. First, 1 liter of whole blood was removed, then to make space, and then I was infused with 2 liters of young plasma. YFFP is the trademark from Spectrum, and it's thoroughly screened and matched from donors 18 to 25. Dr. Julie Caseberg, who I recommend highly, Everspan Life, she was my doctor. Subjective observations. Now, I'm more of a numbers guy, but how you feel is important too. And since then, even shortly after, life just seemed better. Okay, you can argue that that's subjective, but things I had looked at, I mean, just some background. For a couple weeks, I was really had a very demanding schedule. I was stressed. I was a little bit weary, but still, a few hours after the infusion, I was on an airplane back here to Florida, and I remember it's kind of funny coming off, walking through the airport. The things I'd looked at a lot of times before just seemed interesting, more interesting than before. Add to the stress, my computer had crashed. Word to the wise, back up everything. I use iDrive, plus I manually back up everything once a day. It's when your life is on that thing, it causes some upheaval in your life. But I took it in stride. I knew what I needed to do to rebuild. Even a couple times while I was driving, mostly in stop traffic, I took it all more in stride. Now, I feel I have more clarity about making decisions and about the road ahead. I'm better able to plan and execute actions and calmly, efficiently, and effectively. I'm not tired. Like yesterday, I was really churning all day long, but at the end of the day, I still had more energy. I wanted to work more, but I knew we had the meeting today. I should probably rest just a little. But I seem to be coming up with more creative solutions. Again, let me state that I'm learning new ways to evaluate the results of this. But for now, I'm just sticking with my what I've used in the past, objective measures. Labs, glucose was down after a week from 109 to 96. There was a slight hemoglobin A1C reduction, zero point 0.1, not that much, but I'll take it. Consistent with the blood removal, the hemoglobin and hematocrit decreased. I had one test 2 days after just to see what was going on, and then another one a week later. These were on the rise. So I was replenishing blood cells. Blood pressure, normally it's about 118 over 78. After consistently around 115 over 72 to as low as often around 108 to 65. Okay, here is my spreadsheet. The calculated phenotypic age was 16% improvement. Okay, that's not monumental, but it was pretty good before it. So the marginal increase, I think something is to be said for that. For cognitive, the trail making B test is something I've relied on. That was 56 down to on the 27th, 46.3 seconds, and that's a 17% improvement. On the number memory human benchmark, the first day I think I had some allergies and I was just still working hard, kind of excited, felt a little bit off. So I was a little surprised that I didn't get a bump in my normal average for number memory, but verbal memory, I could tell. And I've done this time and time again. If I'm not really feeling my regular self, the cognitive numbers like in CNS vital signs and human benchmark go down. So it was 26 that day. So I tried it the next day. So you draw your own conclusions there. I suggest that we throw this one out or average the two at least and go with that. Okay, reaction time. The day after 265, the day after that 249. So 257 average, 9% improvement. Balance test, legged stand, which is a pretty good test of your strength as well as balance. 50 seconds initially, 59 seconds, 18% improvement. 30-second chair stand. In this case, there was not a significant improvement. I think most of that is muscle or rebuilding muscle or something. So I'm going to do all this stuff in a few more weeks. Exercise stamina on an elliptical machine. I had a 6.7% improvement. Yeah, that's good. I'll take it. Ask an athlete if they can improve their exercise stamina by 6%. And you real scientists out there may say, well, that's not statistically valid. It's n equals one, but ask an athlete and see what they have to say about an increase like that. Claude AI, yeah, I use Claude too, with the usual caveats about hallucination and all that. But here it was pretty straightforward. I asked it, compare the two lab reports, and it came back with pretty much echoing what I had seen. Cholesterol went down a little bit. C-reactive protein, it was actually up still a couple days after. I mean, let's face it, you're introducing something new to the body. The body reacts until it settles down and gets to know it. It was like 2.3, something like that, a couple days after, but then it settled down. Actually, 0.76 is more in my normal range. I'm thinking that the 0.58 was a little bit unusually low, I mean. So here's the Claude AI assessment. The plasma infusion showed promising age reversal with a reduction in biological age and improvements in metabolic markers. However, it gave me a caveat. It picked up on the hemoglobin. I know what's going on there. No big deal. The Oura Ring, I'm getting more deep sleep. Usually the deep sleep is like 25, 30 minutes, and many nights I'm getting like over 1 hour. And I'm going to have to download the numbers and analyze them, but I'm pretty sure I'm getting more REM sleep, over 1 hour many nights, and usually it's like a half hour there. Here is the take-home point that for me is very, very important. I've had glaucoma. I've had like, I've lost track of all the 6 or 7 surgeries in the left eye. I'm scheduled for a surgery in March. I'd really rather not. So for me, the eyes, virtually everyone has some form of Achilles heel, or maybe two or three. I'm very healthy in most aspects. I do a lot of stuff to maintain that health, but with me, the eyes, here it gets personal, okay? The E-chart test, I was utterly amazed. Left eye, I was able to read 2 more lines on that E-chart. Now I have a lens in here, and I know there's other things going on in vision other than your lens. But the right eye, I have a growing cataract in. I dropped 3 lines. So the pressure in the left eye, last reading was 21 and 22. They checked it twice. That's in the danger zone. 18 last time, which is a little higher than I'd like, but out of the danger zone. So the right eye was down from 15 to 14. I don't have as big of problems in the right eye. So I'm going to be going back and getting more checks and hoping for a downward trend and we shall see. And hopefully, I can skip through that surgery that I'm scheduled for in March. Actually, I've had different kinds of surgeries where they cut. I've had a tube implant, a trabectome, which is like a roto-rooter in the eye. The thing I'm scheduled for in March is actually a kind of a laser treatment. They're going to amp up the laser from last time, but still they put you under, they roll you down the OR like a like a scalpel type surgery. So I'm ready for anything, but I'd rather not. And there are potential risks to all that. Here's something. I was scheduled to get a shot in the eye that day. I have, I do have some early macular degeneration, but I also have, or had at one time, retinal bleeding of the tiny vessels in the eye. They're rather fragile. And it was a kind of a big problem for a few weeks. So every 6 to 8 weeks, I go back for a shot in the eye. That is not me, but that's what it looks like. I've had so many shots in the eye, surgeries, instruments in the eye. I take all this stuff in stride, but I'd rather not. I was scheduled for a shot that day, but I showed the retina specialist what I had been doing. He took a look at the numbers for the E-chart test and the pressure, and we agreed that we can watch and wait. So I'm scheduled in another 5 weeks to go back, and they do a scan in addition to the specialist looking in the eye, and the scan shows whether you have swelling, and my swelling was down, no swelling. So you think I was happy about that? Okay. There is a typical trajectory to this. Immediately, I'm told that you immediately notice more energy, which I did, as well as some other things that I already shared with you. The greater repairing throughout the body becomes noticeable about a week throughout the next couple of weeks, then continuing upward, but at a slower pace for the next couple months. And the young plasma, or YFFP, remains in circulation up to 4 months, but another specialist tells me that's typically 6 months. However, I have a friend who went to Texas for the treatment about a year ago, and she's claiming that she's still experiencing the positive effects of it. So her problem was mostly like hormonal.
I'll be very quick. I, like you, have been, gathering old historical data from, blood tests and so on, and then taken measurements since then. By the way, largely thanks to Ranjan, who got me involved in a Stanford study that's going to be taking my blood regularly, so I can have a lot of data. But and there were some things that already show interesting improvements and changes anyway. But the thing, I want to advise everybody one thing, which is you should probably start your personal biometric testing now so that you're on a plateau. If you ever get the therapy, then you can see an improvement on a plateau that you can't see when you're on the learning curve. That's actually kind of important. But okay, for me, I'll just stop by saying that I'm pre-diabetic, like many people my age, and one of the symptoms for me is that my feet get hot when I'm sleeping at night. I have to actually stick them out the bottom of the covers, and and I noticed like the week after the therapy that had gone away, and I was most curious. I wasn't sure what to make of it, and uh, and then it turns out I love Chinese foot massages. And I go in, I get the strongest guy in the building, and I get him to do me because I really like the strong massage. Well, what do you know? Last week and then this week I went in. It hurt so much that I was squirming like a worm, and actually had to tell him to calm down because all of a sudden my nerves are more sensitive, and I take that, I don't like the pain, but I take that as a positive sign. And that's a little subjective, but it's pretty powerful from where I sit. Thank you very much.
Well, I'm going to jump in before we get to Tom. I mean to John. You've touched on some things that I really didn't get to here, but it's the quality of our life. It's the end results that we are seeking. And I break them down to physical, cognitive, and emotional, even spiritual, if you're into that sort of thing. And I'll show my slide on that later. But dealing with long-standing problems, that's kind of a big deal with all this. So, John, thank you. You've been patiently waiting. What would you like to ask?
Okay. Want to emphasize that I think it's very important whether a given intervention is a permanent has any permanent effects or whether it's a temporary effect that goes away in a month or so. In that context, I'm a little surprised that you did not do, or you didn't mention at least a Horvath epigenetic assay to see whether your epigenetic age changed significantly, because I think that has its own problems, of course, but it's
Yeah,
probably an indication of whether you're making permanent exchange, permanent things or not. My other
I can speak to that.
yeah.
just a, let me
Please do. This is important. Go ahead, Tom.
in Steve's presentation, he mentioned that the convoys had seen some epigenetic changes, and I don't think that's true. What they reported was that they had some kind of protein assay technique that they used to measure some kind of age, and that improved, but they did not do a Horvath type epigenetic measure. I think the epigenetic measures are a problem because different companies give you different ages that can differ by decades. But it's important to choose one and then see what changes happen. That's much more reliable than bouncing around from company to company. That's all I wanted to say. Thanks.
A couple
Please.
things on that, John. We've had, and again, there's been 1,000 people that have received this treatment, so that's a little more than 5 rats. But we've had especially type 2 diabetics respond. Some of them normalize their A1C and their glucose immediately within 2 weeks. It really is very quick. And it's lasted for over 5 years. We find the eyesight improvements to be very immediate. I put on the chat that we had a Stanford transplant nurse with wet macular degeneration deemed by Stanford to be incurable, be treated with monthly eye injections for 16 years, received 3 liters of plasma. It went away in 2 weeks, and it's been more than a year, and it hasn't come back. So we see this. I've been getting it about once a year, and try to stay ahead of the curve. You know, the more the better, but right now the FDA is preventing it from being reimbursed. But be careful about epigenetic testing. Even Horvath says it's being promoted for a purpose it was never intended. We know that just the time of day you take that test can vary the result by 5 years. Just the time of day you take the test. It was never intended to be the measurement that it's being marketed and promoted to be. It does not show extreme fasting changes. It does not really show young plasma changes. So it's very limited because a lot of what goes on with young plasma is in the extracellular matrix. So it's a very misleading marketed product for money that even Horvath says himself was only intended to be a marker over massive population sizes in a very general sense. And we found, speaking of AI, the larger the databases, like on this Obnick age, when they included the Harvard database, then the more hallucinations it has. And we really monitored it for a couple years, and it really goes off the rails. So be careful to put any value in that because it's not warranted. Anything that varies 5 years on your rate of aging based upon whether you took it at noon or midnight should be fundamentally discarded as a reliable value.
I don't quite agree in that it seems to me that
That's a published fact.
what you're looking for is changes, not absolute values. And if you do the measurements carefully at the same time of day, when before and after a treatment or something, you can minimize the variations you're talking about. So I think it's one of the only games in town. It's perhaps not ideal. I agree with that, but it's a measure that ought to be looked at a lot more than when people are doing these massive interventions than otherwise.
Go ahead.
It's been shown to have some real massive errors and extrapolations into conditions that don't exist. But I'll just tell you briefly, Johnny made the point, I made the point earlier. When you do a heart transplant, you've got 4 hours, but we learned that from experience because you really can't measure life. When you do in vitro fertilization with a preserved egg and a preserved sperm, you actually don't know if that life is going to get conveyed until the egg becomes fertilized. When you have somebody hit the floor and you hit them with a defibrillator, you don't know if you're going to revive them until you do. If somebody washes ashore after drowning and you apply CPR, there's no test to tell you if it's going to work until it does. So be careful when you're dealing with life as to how you think you're going to measure it, because fundamentally we can't. We know when you have it, we know when you don't have it. It's like a lot of these people who get into cryopreservation. The fundamental fact is, if you're dead and they freeze you, you're never coming back. You have to be frozen like those roundworms in Siberia before you die. So there's a lot of misinformation going on here. And I understand it's called the Flexner system of science that John D. Rockefeller and Andrew Carnegie propagated in 1910 in the United States, that's German-based. If you can't prove it, don't use it. But unfortunately, when you're dealing with quantum biology, we're in a realm we really don't understand. And so don't necessarily hang your hat on some of these promotions of products that are being promoted as a point of measurement for a purpose they were never intended.
Yeah, Tom, with one, well, I guess I'll mention their name, True Diagnostic, did they implement a new algorithm or brought in a new data
Yes.
set which somehow changed things and
Well,
resulted in a lot less accuracy?
yes, they originally started, it came out of New Zealand, a small community called Dunedin. And they had a individual from that community go over to Duke, and he brought the database just because they had kept it. And then as they decided to make the database bigger, and they did a deal with Harvard, which had massive files, they're now trying to use AI to make connections between that database and their epigenetic testing. Although you will notice True Diagnostics does not warn you that you must take that test at the same time every time you take it. They don't even tell you that much. And so what we found was that the hallucinations from AI became uncontrollable. It hadn't got a clue, and it was trying to make connections between subjects where there was no connection. And it just got more erroneous, not more precise. But the whole purpose, Diane Ginsburg has spoken directly with Steve Horvath, and they're like, and you may notice from Altos Labs and the Levines, they're not out there promoting this like that. And so what you have is a group that is out promoting something for a purpose that was never intended. And actually, the more they try to use AI inappropriately, the more erroneous the outcomes become. And they don't even give you the fundamental basics of even how to take the test, because I think they're more concerned about marketing it, and everybody's getting run down a rat hole. That's my experience with it. And again, not just plasma, it doesn't even show drastic changes in your diet like extreme fasting. It doesn't even reflect it. And exercise. So it's just a marketing program. And unfortunately, because of that Flexner mentality we have entrained in us since 1910, we always want to find definitive information. And Stephen Hawking said the entire universe is at a quantum level. Michio Kaku has said if we don't understand that, we don't even understand biology. But the fact of the matter is, look through a microscope or look through a telescope, we understand about 4% of what we see, and it's frustrating, but that's the reality. But then make it simple. We know we're at a peak biologically in an 8-year period when we're 18 to 25. Mother Nature only wants us to reproduce. We could be a praying mantis and after sex have our head eaten off, but we instead go into a very long decline. But we're useless biologically at that point. And at the age of 26, we start becoming dormant. And the milestones are 34, 44, 60, and 78, which I'm 72, and I can see it coming. So the other misnomer that goes on is you can reverse aging. I'm sorry, that defies the laws of physics. You're not going to reverse your age. All that you can do is biohack yourself with young plasma. And Stanford found it goes both ways. And again, I'm 72, so I'm looking for an 18-year-old who wants to be old really quick because it is volume related. But when you biohack yourself, as we know, when we're young, you get wounded, you heal quickly. When you're old, you don't. It will make you the best version of what you are. It's not going to make you different. It'll make you the best version biologically of what you can be now. So this whole thing about you're going to turn back the clock and become a younger person is not true. That defies the laws of physics. So I advise everybody, don't wait, baby. The sooner you do it, and longevity really belongs, which is the true purpose of apheresis, when you're young. Detoxify the kids before they damage themselves. And we can turn around the medical environment that we find ourselves in. Is it's useful to do it frequently when you're young. And then, hey, all us old people can take that byproduct and use it to help ourselves. But we've got this mentality that is in running in reverse. And I can go on forever, but I'll give you all a break.
Yeah. I don't know if you noticed Keith's comment. Matt Kaberlin just sent in identical blood samples to True Diagnostic, and it showed 13-year difference for ohmic age. So there you go.
There's a lot of snake oil out there.
Yep. So I'm just thinking with my success story, with not just the biomarkers, but practical functions that really have a deep meaning to me with measurable improvements in my eyes. And Walt, his thing with the hot feet, hot tingly feet, I don't know, I guess you could look at the bright side of life with that and reduce your heating bills or something. I don't know. But, practical real life stories like that. Well, yeah, it's just one now two, but they start to add up. And then the Stanford nurse and others. We should feed all that into AI. So, Josh, you have a comment. Please go.
Yeah, I don't think this is a question. I just want to comment that I hear claims that exosomes are not damaged by freezing. There are no studies, correct me if I'm wrong, comparing outcomes with frozen exosomes and with fresh exosomes.
Okay.
I'll
Then,
I'll answer that a little bit. We have nematodes that came alive after 46,000 years, and then we had woolly mammoths and cave lions that were dead as a doornail, and they ain't coming back. They're like Ted Williams. They're not coming back. So you can't create the same life without life. So it's simple. Anybody wants to do the study, go spend the money. But we biopreserve our plasma at minus 80 degrees centigrade. The Siberian permafrost is at minus 5 degrees centigrade. But we're just trying to take it to the point of breaking the bag the plasma resides in. But you've got to keep it alive. And so it's just obvious that if you take an exosome out of whatever you source it from, or GDF11 or whatever you pull out of plasma and then you kill it, it is not going to have the same ability to convey life as that living substance does. When you capture it, you biopreserve it, then you revive it as you put it into yourself. It's just obvious.
very good. Dennis?
Johnny, can you put some numbers to the figures that you spend, doing the procedure? I'm talking about dollars. So pretty simple question.
Is that a way of asking how much does it cost?
Yes, yeah.
Well, different practitioners charge different amounts. Normally, the cost of the young, fresh frozen plasma, the normal cost is $5,000 a liter. Right now, there's a special going on, 15% off. And then I've been to Texas and I've not only toured and met the management and some of the people working at Spectrum Plasma, but also been in the facilities of several of the doctors there and others I've met like at RadFest and others I know personally. There's still a couple in Texas I don't know. I'll just suggest that you do your due diligence, but talk to me before you make any commitments, and I'll explain in detail why as to what the costs would be. But for depending on what you have beyond the cost of the plasma, which is fixed, it can be for the doctor's professional services, which they earn, it can be as low as $1,000 to as much as 20,600, as I recall.
Yeah, thank you, Johnny. I'll talk a little bit to that. When you get 3 liters like Walter did, he got just one component, 5.5 trillion exosomes, and they're all alive. And I challenge anyone, Josh, you can do the math, go call Chimera and ask what it would cost to get 5.5 trillion of their dead exosomes. And that, of course, he's got the 10,500 proteins. And I ask anybody with GDF11 what the other 4,999 peptides would cost you, or the steroids on the hormones, or et cetera, et cetera. So it's $5,000 a liter from us to the prescriber, but as Johnny says, it needs to be put into you by the doctor that writes the prescription. It is volume related. We've had our application at CMS to get this reimbursed at the same level convalescent plasma was reimbursed, held up for 2 years, because the FDA, who just put another warning out yesterday, finds this the greatest threat to their pharmaceutical industry that exists, because 20% of all pharmaceuticals are derived from plasma. 90% of the plasma collected in the United States is collected not by the Red Cross or blood banks like Spectrum. It's collected by the pharmaceutical companies as a raw material for their product, which they then charge 10 to 30 times as much as Spectrum plasma does. And again, they kill it in ethanol before they even deliver it to you. So they don't ask you the sex, that what your sex is. They don't tell you the age of their donors or anything, because it's all at that point dead and it's immaterial. So there's a lot that's involved here. I can just tell you that 98% of my colleagues are nonprofits, because there's not a lot of profit in this. I'm doing it because my mother died of Parkinson's. And when I saw Stanford's study originally for Parkinson's patients, I stepped up to do something about it. But it's not a hugely profitable business. But I will say $5,000 a liter is not inexpensive. But when you spend $250 per unit, per donation to test it, you give the donor $100, and then, oh, by the way, you need a facility like you see in my background to actually, that's a good manufacturing FDA registered facility. And oh, by the way, the FDA considers us the finest blood bank they have ever audited, because as Johnny mentioned, we do more tests than are required. It's very expensive, but comparably, and I challenge you, somebody to come up with what 5.5 trillion exosomes would cost from one of these dead suppliers. It's the bargain of your lifetime if you can biohack yourself and have that last. Stanford's first Parkinson's patient said that it lasted 2 years for her. Because again, we keep producing our old plasma, so it's kind of a young versus old fight. There were some comments, believe me, contrary to what the convoys might tell you, or Kiprov or these people, the young, like we all were when we were young, is much stronger than the old. The old falls to the wayside. Senescent cells and all these things people talk about were never a problem when we were young. The young overpowers the old, and it sustains itself, but it's not indefinite. So it really has a lot of time. I would walk around with a IV pump, continuous IV pump of this stuff if I could, but anyways, thank you.
Good. Good. And I know I'm kind of going back on the protocol. I said we're going to try and interweave the questions put in chat. But since Miles, you've had your hand up. Miles, you're such a senior person here. You've contributed so much. You go ahead, and then while others were talking, I was reformatting the actual questions. I'm going to dump them back into chat, and I'll ask while I read them or read parts of them that you kind of follow along in the chat, and we'll rip through the rest of the questions. So take it, Miles.
Thank you very much, Steve. And I see Vince is also here, Vince Giuliani. I really admire the two of you enormously. And I'll tell you for one particular start, and that was you showed me, you pointed to the paper by Morimoto. The paper by Morimoto in 2015, which says, and that was the start of this whole discovery, that At puberty, there is factors that come from the gonads, from the sex cells. And those factors are then spread through the body and they start shutting down certain maintenance processes. They shut down the heat shock response. They shut down the protein maintenance response or the misfolded protein response. They shut down the oxidation responses. The immune system gets shut down. And that's the ultimate cause of aging and of death. I believe that system. And then the system, the body, repurposes all the energy and resources that it took from the maintenance systems and it puts that into reproduction. And then what was wonderful is that I think it was Vince, you said the unit of competition for survival of the fittest is not the individual, it's the species. And the species optimizes its own health. The species has been around for, in human terms, about 7 million years now. It optimizes its own health by regularly killing off the individuals. Tragic but true, but it keeps the species healthy. Now, the nice thing that we kind of know, and this is why I've got one question for Steve. When we look at the deteriorations of aging, we've seen that one part of it is the unraveling of the DNA. The heterochromatin becomes unraveled. It causes, for example, in accelerated cases, it causes the progeria. That's the unraveling of heterochromatin, protein that's supposed to be packed away. And then we also have something which Vince and Steve have specialized in, that the euchromatin, the chromatin which is active, the DNA which is active, is kind of poisoned through life by methylation and is then shut down. So that's a second DNA process, a second DNA deterioration process which underlies aging. And then finally, the third process, which we've also noticed, is at the end of the chromosomes, they wear away so that your telomeres get shortened. Now, what's striking is that all three of these processes, which I believe that they underlie all the hallmarks of aging, all three of these processes are deteriorations of the DNA. All three, I was going to repeat that. I think it's a very important thing that all three aging processes, which we can measure, which we can see, deterioration of the nucleus, for example, it's all deterioration of the DNA. So I did ask Steve, the balance between PGC and TNF, how does that affect the deterioration of the DNA? I think I found ChatGPT was very chatty and said to me, no, there's a connection, but I'm not sure what Steve found. Because I believe that if you can connect those two together, then it's significant. If you can connect up the deterioration of the DNA with this balance, which Steve is talking about, I think that's very significant because we do have, this is one, I want to stop here and then maybe have some comments. We do have interventions for the deterioration of the DNA. We actually do have interventions. The plasma exchange, that is very, very good, and it seems to do some epigenetic improvement, but it's also almost, I think Ira said this, it's almost like a preparation for the deep stuff, which is the epigenetic reprogramming, which you still need. The plasma transfusion or replacement is fantastic, and I need it because I'm pre-diabetic, and I can understand Walter's comment about the feet. I experience the same problem. I'm also getting my glaucoma because of the high sugar level in the blood. I'm getting the same problems. But ultimately, I do believe, yes, the plasma transfusion is fantastic, but we have to go deeper, which is we have to intervene. And the three processes there, which I want maybe just to comment, is that we do have OSK epigenetic reprogramming seems to reset. It resets the heterochromatin deterioration. It seems to replace HP1. It seems to help with getting Layman A back into the nucleus and the internuclear membrane proteins. And then also OSK epigenetic reprogramming seems to help with the methylation problems of euchromatin. And then finally, we know that Liz Parrish, who I very much want to get back on the group here, maybe the next time, she has undergone gene therapy for telomere extension. So we can kind of see, we have a rough outline of what we need to do something significant, starting of which is the plasma exchange, but also then the interventions to repair the DNA, the three modes of deterioration of the DNA. And my question then to Steve was, what did you find in terms of the connection between your PGC TNF balance and the epigenetic systems which we have to reset to repair the DNA, the epigenome? That's my question, Steve.
So I didn't look at that in particular in doing this presentation, but I did a quick Google search before let me read it. Human necrosis factor alpha contributed to DNA deterioration by inducing oxidative stress, which leads to the generation of reactive oxygen species. So TNF is involved in DNA deterioration. And I'll just point out that in establishing a vagal connectivity between the brain and the spleen that inhibits dramatically TNF throughout the blood circulation. I think this is something important that evolution has done to get at this issue, given what I just read from Google. Learning about the cholinergic anti-inflammatory pathway and how to trigger it is an important thing, I think.
Thanks very much, Steve. Thank you. Thank you very much. That's my question, Johnny. Thank you.
Very good. So Walt had made a comment about the cost, and I'm just going to add that running one of these plasma collection centers takes a lot of money, and you have to be very sure-footed in understanding regulatory matters and just a lot of other things. It's expensive. So I'll just leave it at that. I put in I was busy working away here, removing the unnecessary comments and putting everything back into chat. So if I'll go ahead and I think I'll call on you to ask your question. You may have had it answered already, but the next in line was Albert. He had a question for Steve. Did he consider or ask his AI co-authors? So you go ahead and ask your question, okay?
Oh, I'm sorry. I thought you were going to read it, Johnny. Thank you. My question
Well,
was,
it's in the chat.
okay, whether the AI conversation brought up other endogenous substances that increase in plasma with age and may also be agents of aging, that any type of plasma exchange would dilute in the elder person. And I'm wondering if they were considered. My list here is probably not complete. Ammonia, bun, carbon monoxide, creatinine, glucose, homocysteine, ferritin, lactate, uric acid are all building up in some people more than others and considered biomarkers of bad outcomes as they do. Since saline and albumin alone also show a benefit, I'm wondering if the overall effect may be more to lowering these bad things or diluting them than to adding healthy things, because with saline and albumin, all the animal or the human is getting in addition is albumin, and that is something that usually decreases with age. So
I'd like to speak to that.
Before Tom, please let if you don't mind, Steve answer from his perspective, because he's really looked into this with AI, and I'm curious if they had the conversation.
It's not a single thing. There are a lot of different kinds, a lot of different interfaces. It improves by leaps, and it has been improving by leaps and bounds. Hallucination is a problem. There are specific techniques to limit hallucination, and I don't think that's an issue. With regard to Albert's particular question, the thing that I'm not sure I understand your question in detail. It would require a lot of time to think. But the thing about these studies, it's I'm not suggesting that PGC1A is the only significant endogenous important. Is it a protein? I don't know. A protein in the mitochondria in the nucleus that plays an important role. I'm just repeating what the Chen et al. 2024 study said that Josh Middledorf referenced a few minutes ago. They said PGC1A expression was necessary to get the younging effect. And, I'm a software engineer. I'm just in this to live a long time, right? It's not it's not my job. And the thing and I'm always looking for the way to, engineer something or do something more easily. The other thing I noticed, put the question to Claude Sonnet. It may be true, it may not be true. What are some of the most powerful PGC1A promoters? And the answer came back, hyperbaric oxygen therapy. And you heard me talk about PGC1A and telomere length. And I'll just point out that very serious science is going on in Israel by this, I forget his first name, Ephraim Efrati, Efrati, doing studies around hyperbaric oxygen therapy and how it increases PGC1A. I'm not saying that it is a complete substitute for young plasma. I would never say that. I don't know. What I do know is that in his published study, which was ridiculed by a lot of longevity science folks, telomere length increase in older humans and senescent cell count decrease. And those are the only two tests he did. Obviously, more testing needs to be done. But the point I'd make is there are a lot of healthy interventions now, like TEMF. TEMF is an incredible innovation. Guess what? It increases PGC1A. I don't know to what degree, but I've read that it does. This presentation I gave today is just, a first investigation at a high level. I plan to spend the next year on it.
Thank you, Steve. Can you please comment on, because you have given so much blood and you recognize the benefits of simply giving blood without getting anything back, have you found any studies that had an arm or a cohort of the study that was just donating blood or having a phlebotomy done to remove blood and nothing replaced?
I mean, I haven't looked in detail at those and done a serious systematic search, but I have anecdotally just looked at a few, and donating blood does show some benefit. It's not the same thing as plasma apheresis, and it's not the same thing as young plasma.
I'm a blood bank, and I could probably tell you a little bit about that.
Okay.
We know you can only donate blood 6 times a year for a reason. The reason is you're losing cells and it's debilitating. The primary benefit is if you're a European male who doesn't menstruate, hopefully, you lose some iron that you build up. Otherwise, it's debilitating. In the United States, you can donate plasma legally 104 times a year, compared to 6 times a year. That's because it's not debilitating. We don't collect that frequently because we don't want too much dilution. But I bring your attention back to this whole conversation about cleaning out old factors and senescent cells being any sort of equivalent. It's not. We've been doing apheresis for 50 years. In
Second
the
time, I
United
didn't say it
States,
was
let
equivalent,
let
right?
me finish if I could.
I didn't say
In
it
the-
was equivalent, right? I said specifically it's not the same thing. So
Don't even put it in the same league. It's not even worthy of the same conversation. We do it for 50 years, 30,000 times a year in the United States. Most of them are old people. And the machines are principally made in Japan and Germany. So presumably they do a lot of those procedures themselves. It's done worldwide. Japan has one of the oldest populations in the world. So they all ought to be getting young or something, and they're not. So again, if you do something for 50 years and you do it 30,000 times a year, at some point you actually figure out what it's good for and what it's not. So don't kid yourself that somebody's going to do 5 rats and proclaim some great insight. It's not true. So, anyways, I think that's enough for now.
Okay, next. Actually, I did a little write-up and some research. Some of it was my own, based on my own experience. Others was based upon my research assistant, Claude AI, and Perplexity. And it reported athletic and cognitive performance improvements and health benefits of plasma donation in healthy young adults. And, I wanted to be comfortable with the ethics of all this. They were not just a bunch of vampires sucking the life out of these young kids, blah, blah, blah. Nothing could be farther than the truth. There are definite health benefits for plasma donation of people of any age, and that includes young donors 18 to 25. And I tried to put it in chat, but I guess you can't put attachments. If anyone wants a copy of that thing, send me an email and I'll send it to you. So now, moving right along to Josh had a comment or a question. What happened? Well, it was about a study, which I'm going to put back in the chat. Apparently, my running around here trying to do too many things, I closed a Word document I had created, but he asked, I think he commented or maybe asked more of a question about a new Chinese study that regarding exosomes. This is a study in rats, and I have to, uh, you know, I'm not the sharpest bulb in the six pack. Let's put it that way. I'm kind of a practical guy. I don't, I'm really not very good, or probably because I don't like to analyze every little thing with every little molecule. I kind of like a black box kind of guy. I was like this with back in software development, back in my career in medical devices. You plug it in, does it work? I don't need to know all the inner workings of it. I'd like to, but I'm constantly fighting the battle of time, tick tock. So for me, having a therapy that gets results, I don't need to understand everything about how it works. But anyway, I noticed this. I did just put a link to the study that Josh had posted into the chat so you can look at it yourself. It is exosomes in rats. So if you'd like to, Josh, if you would maybe in a better way rephrase what I said and ask a question or comment, you have the floor.
So Johnny, that study that Josh asked about is the study that I was referencing. And what it said is that the exosomes that were injected via young plasma had microRNA cargoes, and there were different qualities and categories of microRNA cargoes in these exosomes. And they did analysis to figure out which of the microRNA cargoes were beneficial. And what they found is that those microRNA cargoes that were beneficial triggered PGC1A expression. The study.
Oh, that's your baby, right?
That's the study. April 2024, remarkably great study. Yeah.
Okay, that's your bailiwick. Okay, very interesting.
Yeah.
Okay. If no more comments on that, moving along to the previous chat entries, which I've recovered. Dennis, Raleigh, North Carolina, USA, to everyone. Tom should hold a separate presentation discussion on what he thinks might be beneficial, both short and long term. And Tom says, yeah. So let's schedule it. Miles or I'll handle this in our next meeting. I don't think we have a speaker scheduled. Let's do it. Or any time, as far as I'm concerned.
Well, you'll notice below that, Johnny, I posted, one of our little journal club, our interactive journal clubs featured Tom speaking as the primary speaker, and that's a pretty good place to start. It's on YouTube. I posted somewhere in this long line of posts. I posted where you can reach it in YouTube, but you could type in my name, Walter Crompton, and find it with a little trouble. And it's not perfect, I'm sure, but Tom has center stage, and he expressed most of his key points there, I think. Sorry.
Okay. Next question. Walt talked about regarding Dennis' post. Oh, no, yeah, you just did that. Okay. Steve talked about Josh. That study reference, well, you just covered that. Thank you. Albert, the benefits of getting young plasma appear more due to its lower levels of harmful agents. Well, I suggest that's not correct. If you want to do some sort of scientific study to facilitate that, actually, that could be woven into. Ranjan and I have been talking about doing a study, sending about a dozen or so subjects to Texas to have these treatments. There would be 4 arms, 3 subjects each. So maybe if we're gaining momentum and Ranjan is gaining more confidence in this as a valuable therapy, we could weave that into such a study should it come to be. So Albert, do you want to
Well, I think, thank
continue
you,
on
Johnny.
that?
That's a great idea to have another arm of any study involving plasma exchange therapies where that arm is only having a phlebotomy on the same schedule as the others who are getting a transfer. And that benefit in longevity would be a baseline assumption that this happens in any method as long as you don't return the plasma or the red blood cells. Of course, in most plasma exchange, they are still returning the red blood cells. But I think that arm is important to see what this baseline is because it does offer the additional benefit of reducing all the risk associated with damaging red blood cells in transit and also accumulating nanoplastics from the tubing, which we don't know how to get rid of yet.
Mm-hmm.
I take it back. We know how to get rid of it in water. We don't know how to get rid of it in blood.
Okay. Miles, you do so much to help us. I'm gonna let you jump the line. Go ahead.
I don't know. You decide if we're going to answer now, later. But I remember I said that plasma exchange is a good start, but I really can't see how we're going to avoid gene therapy because we have to deal with the deterioration of the DNA, the three processes. But Johnny, you mentioned something about being part of a gene therapy group or something. Can you maybe just answer quickly? I think I
Oh,
saw something about that.
yeah. Here in Florida, I'm working with a group that's working on developing a Yamanaka OSK gene therapy to reset the epigenome towards youth or cellular reprogramming. But what do we, that's at least a few years out before it would be ready in humans. We're going to test it in monkeys first. What are we going to do until then? Well, that leads to why I'm staking my life literally, and I know the word literally is literally overused, but literally on the three most effective age reversal therapies to be young again eventually. And the first one is just conventional common sense, nutrition, exercise, stress reduction, etc. But the second one, it's here and now, the young plasma. So that's why I plug that in as number two. And then three that I'm putting my limited silver bullets on is helping this other group in any way I can develop this Yamanaka OSK therapy and helping others along the way in any way I can. But that's basically it. But it's years out before it'll be ready for humans, even offshore.
Okay,
Oh,
thank you
you
very
you
much.
mentioned, here there's, to get analytical, it would be an interesting study regarding what you commented about the importance of resetting DNA or repairing, words to that effect. Am I just generally saying it right, Miles?
Yeah, no, this is very important. Like I said, Vincent and Steve are deeply aware of this. They've been studying this for a long time. The three ways in which DNA deteriorates: the heterochromatin loss, the euchromatin loss, or pollution, and the telomere erosion. And I must say, I mean, it's really. Unfortunately, I think we are being forced, we have to look seriously at the gene therapy. I know it's not yet there, and there's a lot of questions about what does it do, for example, to your memory and all that kind of thing, but it seems to be working, giving results in rats and mice, and they're doing it on monkeys too. So really, I must say, thank you very much, Johnny, for helping this group. And whatever they can do or benefits or advances you have, please share, because I think that in addition to plasma exchange, we have to do the gene therapy OSK, the OSK. That's the next stop on the train line. Thank you very much.
Okay. But if you can, well, Miles, are there, I believe there are tests of DNA to evaluate its integrity and whether, say, before and after a therapy, whether there's been improvement. Is that correct?
No, absolutely, absolutely. I mean, your Horvath testing of the epigenetic age, that basically measures the methylation of euchromatin, plus also a bit
Well,
of
that's different.
and then also with the heterochromatin, you can just look at the nucleus and see if it's busy falling apart. So there are ways of checking these three, and of course, then telomere length can also be measured. I mean, Liz Parrish has had her telomeres extended. And I think, I mean, she looks very healthy. I think anybody who worries about their health should be going down that road, doing at least the telomeres. I mean, Liz has done it. She's 50 something. She's looking fantastic. So I think in addition to the plasma exchange, have your telomeres extended, and then seriously look at OSK, Yamanaka reprogramming. I mean, yeah,
Down the
it can
line
be measured.
when
It
it's
can be
ready.
measured. Thank you.
Uh-huh. Okay, good. To be for the to be analytical, I have some folks who I'm ushering down to Texas to get some of these treatments. I think they're planning on doing it in the next month or two. If anyone here wanted to sponsor this DNA repair test before and after, yeah, we could do that. But we've had I was unaware until now of Walter's personal story about something that was a medical situation that was important to him, that was impacting his life. So I'm just going to suggest while we're analyzing things, we have my personal story about my eyes. I'm pleasantly surprised. I really am. With me, it's personal, but Walter's story, anecdotal as it may seem, but it counts. Things like that count. Nan Little's story about her retreating Alzheimer's. I'll suggest that for those of you who want to do a study, collect people with specific medical conditions, specifically Alzheimer's, because that's Alzheimer's and Parkinson's, because there's published positive results for that, and have them take the young plasma and look at the results in the quality of their life and what not only the measurements, but what they say about it. Okay, next question we have. Okay, Steve, meanwhile, HBOT has been shown to increase PGC1A significantly. Albert, are you here? Are you still here?
Yes, I am. I was about to post a reply to Walter about what's an alternative to the approach of the plasma exchange, and I want to remind him that you and I were just talking about we could just take blood out and see how that works, because it does extend lifespan in humans, and pretty significantly for those who manage to do it every 60 days. The problem is many countries will stop you at 75 or 80, and what do you do beyond that? And you need to either ask a doctor for a phlebotomy and pay for it in many places, or you would have to get wet cupping on your back from an acupuncturist if you live in a state where that's legal. It's illegal in California, for example.
Yeah. Well,
What's your question?
there is a understanding about TPE, TPI, TPR, but just the bottom line, I'm going to suggest that young plasma has components in it that our body, and Diane Ginsburg talks about this extensively. Tom touched on it. Has components that repair things that my soon-to-be 75-year-old body no longer has the components to repair. It's like, blood removal or even plasma donation is like an oil change. That's wonderful. And yeah, the body does regenerate the lost components, and they are younger than than the ones that you let go. So that's good, but not nearly as good as regenerating young plasma. I mean,
Could you do a
the
study,
components
Johnny?
in young plasma. But
Oh,
anyway, here's Albert, the question I had. I thought a couple weeks ago when you made your presentation, something that stuck on my mind was that with HBOT, it has temporary positive effects, and please correct me if I got this wrong, but the long-term effects is that it forced CO2 deeper into the cells, and you're going to have negative consequences later. Could you enlighten me on that or clarify?
yes, thanks, Johnny. I think you meant CO, not carbon
CO.
monoxide, not
Right,
CO2,
sorry, yeah.
carbon dioxide. Carbon dioxide is typically flowing out of our tissues, right, into our
Yeah.
bloodstream. It's the byproduct of most of our metabolism. But critically, this heme oxygenase stress pathway I am interested in doesn't produce any CO2. It converts oxygen instead to CO along with other breakdown products of the heme protein. For those who don't know, I should mention it produces iron 1-to-1 with the CO that goes to ferritin if everything goes well, biliverdin that goes to bilirubin, and hot water that contributes to local inflammation if there's a wound or injury. And so with HBOT, when a lot of oxygen is introduced on the arterial side, it displaces any CO that's there. In carbon monoxide poisoning, that could be quite a bit. And the laws of diffusion across membranes being what they are, you can only diffuse up to half of the CO in blood into tissues, or oxygen the other way, because it wants to equilibrate across that membrane. So hyperbaric oxygen pushes all of the CO off of hemoglobin into the plasma in the arteries, and from there, up to half of it will cross into their tissues, and that's where it can cause more harm. Johnny, if it doesn't come back out again right away, it's very clear from CO poisoning literature that the level in your blood is nowhere near as significant as the level in your tissues and organs. And autopsy studies show our organs accumulate CO at very different rates, depending how much heme proteins they have. And unfortunately, our brain has the least, so it has the lowest threshold, and it's usually the organ that succumbs first and kills us because it's so sensitive to CO. The liver, the spleen, they're used to very high levels because they're breaking down red blood cells and use CO a lot. As for them, it's 100 times more than the brain. So it's not a uniform place. I want people to realize it really depends on how much heme protein is in the tissue. And the other very low tissue is fat. There's hardly any protein to bind CO and fat. At the other end, you bind a lot in muscle as well as in blood and liver and spleen. Thanks.
Yeah. So, yeah, thank you for the detail. And there's that and a lot more up on our YouTube channel. Last time Albert made a amazing presentation. But so then let me boil it down to my two actually take-home questions. Are there unexpected potential or likely negative consequences to HBOT therapy where it somehow pushes the carbon monoxide into the cells, or for whatever reason
I
that
hope
could
this
cause a
answer,
problem later?
thank you. I hope this answer makes everybody happy. Because CO and oxygen are both hormetic in terms of their dose response in humans and other mammals, there's a sweet spot. Too much is toxic, too little is toxic, and it really depends on where the person or the animal is. If they're low in CO, giving them more moves them towards the sweet spot, and it's beneficial in lots of studies that have been designed to look for that type of effect, and they find it. On the other hand, if they are already in the sweet spot or above it and you give them more, you see worse outcomes. And there's studies that look for and find that as well. They're not contradicting each other. They're just looking at people on different points of the spectrum. So I can't say a blanket one way or the other. It really depends. And I urge you to think of CO and oxygen like vita gases parallel to vitamins. 0 is not the healthiest dose. It doesn't get better if you keep going up. You have to stay in some healthy range. And that does vary with gender and age a lot. One of my comments here is about how women go through this cycle that men don't. And looks like they're aging and then younging, plus or minus 50% of the normal average red blood cell lifespan across the menstrual cycle. And of course, men don't do that. So I do think, in answer to Steve's comment before, and yours also, we can reverse aging. Well, women can, and they do it every month. It somehow is causing, I think, systemic effects that help them live longer than men. Thanks.
Very good.
Albert,
Well,
isn't it correct to, excuse me, may I? Yeah. Albert, isn't it correct to say that pretty much everybody in these pictures that are not spring chickens, we probably all have an excess accumulation of carbon monoxide in our tissues. Is that correct?
No, I can't say excess. Sorry, Walt. We have accumulation as we age. And clearly we all peak, right? Around 40, 50, physically, mentally, everybody sees it. There's some peak there in growth, after which there's too much of the bad thing and less of the good thing. And I urge you to just think of the CO that accumulates in people as they age as a glass that's got a little bit of water in it when you're born, and it just keeps increasing as you age, leaving less and less room for the gas on top. Unlike iron in this hemoxygenase cycle that is recycled all our lives, we don't make new iron. We just recycle the old iron and any new iron we may ingest. But
Well, so you are saying that elders tend to have an excess of CO in their system.
I'm not saying it's an excess. They just accumulated across their lives.
Well, if it's accumulated and you don't need it, it's an excess.
I don't know where where the exact sweet spot is. It comes back to that hormetic curve. Obviously, when you die, you had too much. When you die of CO-related disorders, you had too much. But there are deaths, of course, that occur when people seem to have just the right amount of CO, and it's no protection necessarily against many things. The correlation with aging is, however, pretty consistent with these other markers like the RDW and the red blood cell lifespan. So I urge us to focus on the ones that are more commonly measured, that are a lot easier to, I think, make judgments about. And certainly with red blood cell lifespan, the shorter that gets, the closer you are to death and a very short overall lifespan.
I've been making an analogy like imagine that your yard is extremely overgrown. You walk through it and you get your eyes poked by branches and whatever. And then you bring in a gardener, and over a period of a week or so, the gardener, clears everything out, and you walk out in the yard. It's clean. You feel great, and there's like an immediate effect, which is you feel better. You're not getting your eyes poked by all the branches or getting poison ivy on your legs and all this, but it's all going to grow back. So the young plasma infusion at best provides something like that, where it kind of corrects things, does some repair, but that repair is reversible over time.
Well, I'll
I didn't want to
suggest
give
there's so much we don't know about this, Walt, and I'll suggest that maybe some
Maybe.
things are getting reset towards youth, therefore repaired as well as they can for the long term. I'd love to do a scientific study to find that out, but at any rate,
well, one
around
interesting
every
study
four
that
to
was
six
done.
months, and the body starts growing more weeds. So, okay, go ahead.
One interesting study that has been done is the longevity of Olympic athletes by the type of sport they did. Looking
Yeah.
at athletes who won medals in the mid 1900s, early 1900s, and seeing how long they lived, it is clear, and I'm going to mess up the sports, but the general idea was that those who did long distance running or difficult running like hurdles and marathons live longer than those who do shorter burst activities like shot puts or javelins or pole vaults, where they're exercising and probably training as many hours of the day, but much less minute ventilation. And it's, I believe, related to how much ventilation the long distance athletes are generating. Even though exercise is stressful and causes them to make more carbon monoxide while they're doing it, they're giving off more in total, I think, because of their increased breathing, whereas stationary athletes aren't doing that. And so for all of us, we can reverse the clock by exercising at a much higher rate or doing other things to increase our minute ventilation that don't require running or such strenuous exercise. And I recommend to people just doing rebreathing exercises with a cup or mask that has a hole in the bottom, rebreathing like a paper bag with a hole in the bottom. And that can boost your ventilation 50% per minute just sitting on the couch.
May I speak 1 minute because I have to leave in a short time?
Okay, go ahead,
Okay,
Didier.
so the question I ask in the chat and that you copy again. So all those discussions are interesting, but I never understand why you are not testing on what's the effect on longevity, because during all discussions that I was hearing, there is almost nothing on a long-term effect. So we are pretty sure that there is an effect on the short term, even if the placebo effect can be important, but we don't know at all on the long term. And a long time ago, a few years ago, I proposed to the convoys to have a longevity test on rats, and they refused, actually. So why are you not doing that? Doesn't cost a lot of money. Yeah. And that's my first question. And my second question is, am I wrong or right that there is nothing on long term on humans? Thank you.
Okay, so it sounds like the first part of the question, why don't we do longevity studies in rats? Well, of the thousands of things that I have to do in a day, it seems to me that would be useful, but of lower priority than others. I guess it's difficult to ask why I don't, anyone to ask why they don't do something or why something doesn't exist. But if you would like to propose and I'm interested in humans, really. TikTok. And if you would like to propose and get funding and design a longevity study using young plasma in humans, I'll certainly sign up to be a test subject.
There's
I'm
evidence.
working on, yeah, let me add something. I'm working on my own N=1, N=me longevity study. So let's talk about it. You are cordially invited to my big birthday party, December 17th, 2049. Mark your calendar. I want you there. So next.
Johnny, there's evidence that what kills rats in old age is quite different from what kills human beings anyway. So longevity studies are very limited in their implications.
Yeah. Yeah, that's the answer that,
Yeah, but
I didn't think of.
the problem is many people, to begin with, the convoys were saying that it was radically better for rats, and there was never approved because there was never a study on the longevity. What I don't understand. And okay, of course, humans are more important than rats, but at the beginning of the speech today, you were also speaking about rats. So yeah, why did never somebody made a study with plasma on longevity of rats? Since there is no study also on long term on humans, I mean.
Okay. Well, I can't think of anything beyond what I said before to address that.
Can I say something?
Yeah, please go ahead.
Is doing at least two studies on mice, well, with mitochondrial replacement, and they have very promising results, which I probably am not authorized to talk about, but which are sort of blow the lid off.
All right. I hope Tom gets it going real soon and us humans. And I recognize you're a part of that circle, and yeah.
Johnny, have there
One
been
one
any
thing that
studies
comes
of
to
people?
mind. Oh, go ahead, Albert.
Have there been any studies of people or animals that just got a plasma exchange from a younger animal without giving any blood? Obviously, can't give too much because you would over suffuse them, but I'm thinking of a study that might give a unit of plasma exchange versus withdraw a unit of blood and compare those two arms for their separate effect versus doing both, removing blood and returning the red blood cells as we currently do with the young plasma. Have you seen that?
I haven't seen it.
Anybody else can comment? Has that arm been tried? Just giving the plasma? Well, there's an obvious harm to try. To the extent that we can do it without harming the animal, I think they could take certainly another unit or two.
Okay, anyone else?
I guess I could make one more comment about the difference between, TPE and young plasma replacement. We've all read about that as you age, certain large proteins they become more problematic, and that's not hard to believe, considering that it requires more inputs, and more inputs means more chances for problems, and I don't see any way that pulling out old plasma is going to fix that. Whereas inserting young plasma, at least temporarily, restores those large proteins. I'm speculating, but it seems really sensible.
Well, okay. I guess I'll close it up for now. Going.
Thanks, Johnny.
Yeah, well, thank you.
Thank you for your talk. It was very popular. Thank you very much. Thank you very much.
Bravo.
Bravo. Thank you, Steve, and
bet.
everybody else who asked
You
such
too, Johnny.
great questions and comments. Okay, signing off
Adios.
now. Bye-bye.
Thanks, Johnny.